Hello there and welcome to the memory video of OCR J276 GCSE Computer Science. As you can probably tell by the title, today we are looking at different types of memory. So specifically we're looking at the RAM and the ROM, what they do, the characteristics of them, and then having a look at the usage of both virtual and flash memory. So there's the learning outcomes for today's lesson, so you can see where the pitch is at and what we're going to be doing. So without getting started, without any further attention, let's get going. So the RAM, which stands for Random Access Memory, holds anything which is currently open inside the computer. So the RAM sticks, which are plugged into the motherboard, look a little bit like this. Apologise for my artistic lack. These parts here, which we've got indicated by the arrow, are little chips, and then this plugs straight into the motherboard. So the RAM, Random Access Memory, plugs straight into the motherboard so we can take it out, put more in if we want. Most motherboards come with multiple slots, so then we can buy another stick of RAM, which we can then plug in. If this is 8 GB of RAM in this stick here, we can then plug in another 8 GB stick here, which will then give us in total 16 GB of RAM. The more RAM we've got, the more stuff we can do with it. Every time something's open inside of a computer, a copy of it is sent from the hard drive, which we've got over here, and it gets put into the RAM. So I've got Google Chrome open at the moment, so a copy of Google Chrome has gone from the hard drive and a copy of it put it into the RAM. And then when I close Google Chrome and it's all done with, it then goes back to the hard drive. So the whole idea of RAM is that it's used for things which are open. Because if I've got the CPU over here, first place it checks for information is inside itself in the cache. If it doesn't find anything there, it goes to the RAM. And then if it still can't find the information, it takes itself over to the hard drive. So the information going straight into the RAM means it's quicker for the CPU to find the information because that's the second place that it looks. If we got rid of the RAM and was like, right, okay, there's no RAM, and the CPU was looking inside for the instructions or data it's looking for, and then it kept having to look over the storage, the computer would run a hell of a lot slower. So using the RAM here as a little stepping stone between the CPU looking for information and the storage device, it just speeds up the process and how the computer works. RAM is considered to be volatile memory, and what this means is when it is working, when it's operating, there's information stored in there, but then when the PC loses power, the volatile memory is emptied. If we're thinking about the RAM, if in this scenario we've only got 16 GB of RAM, if the RAM never got wiped, it would eventually get full up. The computer wouldn't respond, it wouldn't do anything, and the user wouldn't be able to use it. Because it's volatile, because it wipes itself when the computer restarts or when the computer loses its power, that means we can then put more information, fresh information, into the RAM. If we're now going to look at ROM, ROM is different to RAM. Instead of being a little chip, instead of being a RAM chip, ROM is a little chip which fits directly onto the motherboard. ROM is non-volatile. That means every time we turn off the computer, every time it loses power to it, the ROM retains its memory. So it's just like a CD or a USB stick. Those are other examples of non-volatile storage. It retains what's in here. The main thing which is included on the ROM is the BIOS, which stands for Basic Input Output System. And this is the thing that when you start up your PC, it does all the basic startup, getting inputs working, making sure the electricity is going to the correct places, and generally loading up pieces of hardware to be used. ROM stands for read-only memory. So as random access, you could read to it, you could write to it, you could edit it. ROM, read-only, you're only reading it, you're only viewing what's in there. Because with the BIOS, which stands for Basic Input Output System, which is what starts up your computer, if you fiddle about with your BIOS and it goes wrong, you could potentially do a lot of damage, and then you'd have to end up replacing your ROM chip, which 9 times out of 10 means replacing your motherboard, which can be quite expensive to say the least. So we looked at RAM, we've looked at ROM. What I want you to do now is share your knowledge of RAM and ROM, looking at what it's used for, what's the difference between volatile and non-volatile, and specifically why does the RAM need to be volatile. Give the video a quick pause, and then we'll crack on with the next section. So now we are going to have a quick look at flash memory, which is also known as solid state memory, which we'll come on to in a second. So imagine we have got here a circuit, and then we've got a little arm here, and if it's touching, that means it's going to be a 1, and then if it's not touching, we're going to be equal to a 0. This is flash memory. This is how RAM works, this is how USB sticks work, this is how solid state works. We've got circuits. If there's a connection going to it, it means we've got one value. If we've not got a connection to it, we've got another value. This is how RAM works. RAM is a type of flash memory. It's very quick to read to, it's very fast. You can see what's going on quickly. It is quick, but unfortunately, it's expensive. So that's why, although it's coming down a lot in price recently, when I was in school, certainly USB sticks were a new technology. They were very, very, very expensive. But thankfully now, prices are going down. So just what I want you to do, to make a few quick notes. What's flash memory? Why is RAM an example of flash memory? Give the video a quick pause and we'll move on. So the final thing we are going to be looking at today is virtual memory. And we already know from what we were looking at earlier, we've got our RAM stick over here, and that is going to be an 8 GB RAM stick, and we've got our solid state drive this time. Our solid state drive, and that is, say, going to have a capacity of 240 GB. Imagine this scenario, if you will. We want to load up Photoshop, we want to load up Warcraft, we want to load up Farming Simulator, and we also want to do some After Effects all the time while streaming on YouTube. Is this 8 GB, if we need to also take into account that it's going to have Windows on it as well, or the operating system of your choice, is this 8 GB going to be enough to store all these plus the work we're doing in them all at the same time? The answer to that is probably going to be no. So what we can do with virtual memory is something which is quite fun and quite helpful to be able to do. What we can do using virtual memory is we can say, right, okay, we're going to take this section, the SSD here, which is going to be another 4 GB. Please note this is not to scale. And we're going to take these 4 GB and we're going to create the illusion that we've got them over here, which is then going to give us 12 GB of RAM. According to the computer, the amount of RAM physically installed in there with the RAM stick here is 8 GB, but we're creating the illusion that there is more memory in there by taking 4 GB from the SSD and saying to the computer, right, you now apparently have got 12 GB, use it as you see fit. This can be very, very, very helpful if you are doing something which is particularly labor intensive, or if you've only got a small amount of RAM in there. When you're using virtual memory and when your operating system's doing it for you, you want to be making sure that the virtual memory itself is being supplied by SSD, a solid state disk, because it is the fastest you can get in terms of read-write times. If you're going to have a magnetic disk on it, you're then going to have the actuator arm still spinning around trying to find the information whilst it's trying to work efficiently as quickly as RAM, and it's not going to be good. So using a solid state device for this virtual memory over here is good because it's the quickest choice. You can then create the illusion that you've got more RAM in there. However, if you're using virtual memory, it is not as quick as regular RAM, because although it looks like it, it's still, the CPU is still thinking, right, okay, if I'm the CPU over here, let's look on the RAM. No, it's not on there. Let's look at the virtual memory. Okay, the virtual memory is actually pointing at the hard drive. So when with using virtual memory, it's good as a general day-to-day usage to get away with different things. If I was going to be a professional video gamer, or if I was going to be doing a lot of graphic design, I would just get more RAM sticks put into my computer rather than relying on virtual memory. So the last thing I want you to do today is give me an explanation of what virtual memory is, how it works, benefits and limitations. I hope this video has been useful for you, and I shall see you later on. See you later.